Okay, in this lesson we're going to review exponent laws. The first two laws deal with multiplying and dividing powers with the same base. So recall from some of your previous courses that when multiplying powers with the same base, we keep the base the same and add the exponents. So looking at our first example, a to the exponent 7 times a to the exponent 5 can be written as a. Let me fix that. A to the exponent 12. 4 to the exponent 3 times 4 squared can be written as 4 to the exponent 5. Okay, when dividing powers with the same base, the rule is that we keep the base the same and subtract the exponents. So a to the exponent 12 divided by a to the exponent 7 can be written as a to the exponent 5, and 5 to the exponent 12 divided by 5 cubed can be written as 5 to the exponent 9. The next exponent law deals with power of a power, and the rule there is to keep the base the same and multiply the exponents. So x to the exponent 5 cubed is the same as x to the exponent 15, and 6 cubed to the exponent 4 is the same as 6 to the exponent 12. Okay, the next exponent law deals with the power of a product. So in each of these cases, within the bracket, we have a product. In the first case, we have the product of two variables, a and b. And in the second, we have the product 2a, as in 2 times a. So when we have an exponent on the outside of a bracket where what's inside the bracket is a product of two or more things, we need to apply that exponent to both parts of the bracket. So this would be the same as a to the exponent n times b to the exponent n. There we go. And the second one, where we have a 2 inside the bracket, we need to apply the exponent 5 to the 2 as well as to the a. And then we can evaluate the 2 to the exponent 5. So 2 to the exponent 5 is 32. So that would be the same as 32 a to the exponent 5. Similarly, when the part inside the bracket is a quotient, we need to apply the exponent to both parts of the quotient. So this first one would be the same as a to the exponent n over b to the exponent n, and the second one would be 3 to the exponent 7 over 4 to the exponent 7. Okay, the last rule to remember second last, sorry, deals with zero exponents. So it says that any base raised to the exponent 0 is equal to 1. So you've got some examples here. 4 to the exponent 0 equals 1, a plus b to the exponent 0 equals 1, y to the 0 equals 1. If the base is negative, so suppose we have negative 5 in brackets to the exponent 0, that equals 1. If we have a fraction to the exponent 0, that equals 1. You can check those last two on your calculator to be sure, but basically no matter what the base is, if the exponent is 0, the answer will be 1. Okay, and when the base is raised to a negative exponent, because that rule is take the reciprocal of the base and make the exponent positive. So 4 to the exponent negative 2 is the same as 1 over, keep the base the same, make the exponent positive. So 1 over 4 squared. Similarly, let's look at this one here, the third one. X to the exponent negative 2 would be 1 over x squared. When the base is a fraction, as in the second one, the shortcut there is to flip the fraction and make the exponent positive. And when you have a negative exponent, as we have here, as part of the denominator, if you move that piece, so the y to the negative 3, to the numerator and make the exponent positive, then you can leave the rest of the denominator there. So that would be the same as y cubed over 2. So basically, if the negative exponent is in the numerator, move it to the denominator to make it positive. If it's in the denominator, move it to the numerator, make it positive. Okay, so we went through those fairly quickly because they should all be reviewed to you, but I'm going to go through some more examples with you. Okay, and if you need a more in-depth review of your power rules, you can let me know and I can go through them with you. Okay, so the ones we're going to go through here combine more than one of these rules in some cases, and we are just asked to simplify each of these expressions, and it does say to express our final answer with positive exponents only. Okay, so looking at the first question, 2 cubed times 3 to the exponent 4, all to the exponent 5. So remember, this is one of those cases where what we have in brackets is the product of two things. So I need to apply this exponent 5 to both parts. And I need to apply my power of a power rule. So what I'm going to have here is 2 to the exponent 15, because 3 times 5 is 15, times 3 to the exponent 20, because 4 times 5 is 20. Now I'm not going to actually evaluate that because it would be a very, very large number. In the next case, I'm actually multiplying two monomials together. So I do that by multiplying the coefficients first. So I'm going to multiply 5 times negative 3. That will give me negative 15. Then I'm going to multiply a to the exponent 7 times a cubed, which will give me a to the exponent 10. Pen does not want to work properly again today. And then we're going to multiply b times b to the exponent 6, which will give us b to the exponent 7. Okay, in the next one, we have an exponent of 3 on the outside of this bracket, which we need to apply to everything inside the bracket. So we need to apply that to the negative 3, to the w squared, to the x exponent 5, and to the y exponent 8. So negative 3 cubed is negative 27. Try that again. Oh, this is just not working very well. There we go. W squared cubed would be w to the exponent 6. X to the exponent 5 cubed would be x to the 15. And y to the exponent 8 cubed would be y to the 24. So again, these are all powers of powers, so therefore I'm multiplying the exponents. Okay, in the next case, I'm multiplying 3 powers together. And I can group together the 2 powers that have the same base. So a to the exponent negative 3 times a to the exponent 6 is a cubed. And then we'll just keep the b to the exponent 5 with it. So a cubed, b to the exponent 5. Okay, next one. Now we have a power of a quotient. So we need to apply this exponent 3 on the outside of the bracket to both parts inside the bracket. So 2 to the exponent 4 cubed is 2 to the exponent 12. 5 to the exponent 0 cubed is 5 to the exponent 0, which is just 1. So that would just be 2 to the exponent 12. Next one, we're going to apply the exponent 3 to everything, so this exponent 3 on the outside, to everything inside the bracket. So everything inside the bracket has to be raised to the exponent 3. So 5 cubed is 125. Then we would have x cubed cubed, so that would be x to the exponent 9. Y to the exponent 4 cubed would be y to the exponent 12. And in the denominator we'll have 27 x to the exponent 15. Now we'll simplify our x terms. X to the exponent 9 divided by x to the exponent 15 is x to the exponent negative 6. But if I write that power in the denominator, I can write it as x to the exponent positive 6. So essentially what we did there was subtract 9 from 15 and change that to a 6. Okay, next one. A cubed to the negative 1 is the same as 1 over a cubed. Next one. Here we have a negative 4 outside the bracket, which we will apply to everything inside. So it will be a to the exponent 12, x to the exponent negative 20, y to the exponent 8. And in order to make the x to the exponent negative 20 have a positive exponent, we'll move it to the denominator. So a to the exponent 12, y to the exponent 8 over x to the exponent 20. In this next one, in the numerator I'm going to multiply first. So 6 times 3 is 18. Group your x's by adding the exponents, so that would be x to the negative 5 and y to the exponent 5 over 9 x cubed y to the negative 4. And now we'll simplify by grouping each part together. So 18 divided by 9 is 2. X to the negative 5 divided by x cubed, that is supposed to say, by the way, that's not very legible, would be x to the negative 8. And then y to the exponent 5 divided by y to the negative 4 would be y to the exponent 9, because 5 minus negative 4 is 9. Okay, next one. You have a fraction with a negative exponent, so we're going to flip that fraction and make the exponent positive. And in the next one, let's think of this one. This one is a little more involved. So you've got negative 5 to the negative 2 divided by 3 to the negative 3. So here we would have 1 over negative 5 squared divided by 1 over 3 cubed, first of all, to get rid of the negative exponents. That would be the same as 1 over 25 divided by 1 over 27. And in order to divide by fractions, we're going to flip the second fraction and multiply. So our answer is 27 over 25. And that concludes your lesson on reviewing exponent laws.